welcome back. Today we're going to talk about GP, geometric progressions, and before that, many of you wanted to know about the weightage. So I'll just quickly go through that. It's already available in on the website also, so you can see over there also. But since you wanted it, so I will just show it to you. Okay, so I hope everybody can see equations. Then you have time value of money, and you wanted sequences and series. So in sequences, so these 4 chapters: permutations, sequences and series, sets, and basic application of differential and integration, all together will combine, have a weightage of 30 to 50% of your mathematics portion. Okay, so you could deal with it accordingly, but this is a good chapter to score marks, so I hope you will be able to do that. Okay. Regarding the 15th sum that you wanted me to do, I will be taking it at the end of the session. Okay, so please don't message about that. So let us now dive into GP. Okay. Yes, Raj, Ritu, Swati, Samya Rajan, Pratibha, Savitri, Ananya, Ashutosh, Sindhu, Arpi, Anushka, Akshata, Tamanna, Aditi, Dimple, Nikita, Ayushi, Shri S, and Ruchika. A very good afternoon to all of you. So let us begin. And before we begin, let us just quickly recap arithmetic progression also. Why we need that? Because many times you will have sums which will contain an AP and GP together. So if you remember, what is the nth term for an AP? It is given by a plus n minus 1 into d, where a is the first term and n is the number of terms in the series and d is the common difference. And for finding the sum of the series, you have 2 formulas. If I know the first term and if I know the last term, I will use this: S is equal to n a plus l upon 2. Okay, where a is the first term, l is the last term. If I don't have that, then I will write S is equal to n by 2 twice a plus n minus 1 into d. Okay. Now the other very important formula, these formula you will be needing every time, so you must know these formula by heart. Sum of the first n natural numbers is n into n plus 1 upon 2. Sum of the first n odd numbers is equal to n square. Sum of the squares of the first n natural numbers is given by n into n plus 1 into 2n plus 1 upon 6. Sum of the cubes of the first n natural numbers is n into n plus 1 upon 2, the whole square. Okay, and if you have to take 3 numbers in AP, they should be taken as a minus d, a, and a plus d. Okay, this was a quick recap about the arithmetic progression. So let us now go to AP. And before we do that, there is this very important thing that you should know. Please make such a chart so that at least for these numbers 2, 3, 4, 5, you quickly remember. Or when you see the number, suppose if I see 256, it should click to my mind that it is 2 raised to 8. Okay. So suppose I see this number 256. So it will quickly help me to understand this is nothing but 2 raised to 8. Okay. So similarly, you should make for this. This also helps in the logical reasoning where you have, the codes, right? When you're creating codes or odd man out, even there also you can see. Okay, if you get something like 255, you can write it quickly as 2 raised to 8 minus 1. Okay, so similarly, so what is this? 2 raised to 1 is 2, 2 raised to 2 is 4, 2 raised to 3 is 8, 2 raised to 4 is 16, and so on. Similarly, if I want to do it for 3, 3 raised to 1 is 3. Let me make it a little broad. Okay. Then 3 square is 9. 3 cube is 27. 3 raised to 4 is 81. 3 raised to 5 is 243, and so on. So you should be able to complete it. Just keep it with you, especially, and then you should know 7 square, 7 cube. Okay. So similarly, at least for all the these numbers, prime numbers, at least you should know. So that is 13 square, then 13 cube. Okay, so those you should usually know, so that at least when you see the numbers, you will be able to identify. Okay, is that clear? You can make this chart with you and keep it with you. Now let us talk about the geometric progression. Yes, Meghna, Aditya, Srishti, Sanju, Aryan, and Srishti. Okay. So now what is geometric progression? Now we were talking about AP. When we talked about AP, what we told was that the difference is common. There is a sequence of numbers, and this sequence is called an AP when you have common difference. That is, third term minus second term is equal to second term minus first term. That is, there is a difference which is same. Okay. Now, when we are talking about GP, we say a sequence of numbers is called as a GP when the ratios is same. That is, second term, third term divided by second term is equal to second term divided by first term is equal to fifth term divided by fourth term, and so on. Okay, so that the ratio is same. And how do I represent it? I represent it by this A, which is the first term. What is A? A is the first term. What is R? R is the common ratio. Okay. So it is AR square, AR cube, AR raised to 4, AR raised to 5, and so on. So nth term is given by AR raised to n minus 1. What does this mean? Is suppose I have n as 2. So what will be the second term? T2 means what? Second term. It will be equal to AR raised to 2 minus 1, which is equal to AR. Okay. T7 will be equal to AR raised to 7 minus 1, which is equal to AR6. Okay. So if I want to find the seventh term, I just write AR raised to 6. And this common ratio R is Tn upon Tn minus 1. Okay. That is the nth term minus a term earlier to the nth term. Okay. So what is the geometric progression? Then the sequence when there is a common ratio, so that between two consecutive numbers the ratio is common throughout the sequence. Now let us see what will be the sum of the first n terms. So you remember what is the sum of AP when L is given, that is the first and the last term is given. I use n by 2 A plus L. So similarly, now here what do we have is this formula is different. Here the formula will depend upon what is the value of R, whether R is greater than 1 or less than 1. So this is important here. Just let me. Okay. This is very important. If R is less than 1, I write A 1 minus. Okay, so this is 1 minus R raised to n upon 1 minus R. So when R is less than 1, sum up to the nth term is given by A R raised to 1 minus R raised to n upon 1 minus R. Okay. When R is less than 1. What will happen when R is greater than 1? What will happen? Sn will be equal to A. R is greater than 1. Then I will write R first. Okay. So R raised to n minus 1 upon R minus 1. Okay. These are the two things. Okay. Now there is a special. So you have two formula. This is the first formula for sum of a GP. when r is less than 1. Second formula is when r is greater than 1. And there is a third formula when series is infinite. Okay. So I have an infinite series, then sum of GP is. So if n is tending to infinity, okay, and 1 upon r raised to n is tending to 0, okay, then s of infinity, that is s up to the infinite term, is given by a 1 minus r. The important condition is this, okay, the important condition here is this, that this will happen only when r is less than 1. Okay, when r is less than 1, what happens to the series? It keeps on decreasing. So there is going to be, it is going to be very, very near the x-axis. Okay, but when r is greater than 1, what happens? It is a diverging thing. So what will happen? Your values of the sequence are going to become bigger and bigger. So it is going to move away from the x-axis. And so what happens is it becomes difficult to find the value of summation. Okay, so this is also a theory question. Very important is that you can find the sum of a infinite series, infinite GP, only when r is less than 1. Okay, or if r is greater than 1, what will be the sum? It will be tending to infinity. Okay, so this sum of the first n terms of a GP, this is very important. Yes, Lisa, good afternoon. Yes, Ritu, when r is less than 1, it is 1 minus r raised to n and 1 minus r in the denominator. Okay, right. So, this is important. When r is less than 1, what is the formula of Sn? When r is greater than 1, what is the formula of Sn? And if the series going to infinity, what will be the value of summation? So, that is a upon, simply a upon 1 minus r. Okay. Now, you also, like we substitute, like we put arithmetic mean between two numbers. Similarly, you also have to put geometric mean between two numbers. So that is also there. Now we are talking that if I have three numbers in GP, then the geometric mean is such that b square is equal to a into c. Okay. So if I have two numbers, if three numbers are there, a, b, c, then b will be the geometric mean. Okay. If a, b, c are in GP, then b will be the geometric mean. And what is the relation? B square is equal to a into c. That is, the middle term will be equal to multiplication of the first term and the third term. Okay. So this is an important thing that helps you in doing sums. So then if I have three numbers in GP, this should be taken as one a upon r, a and ar. And if there are five numbers in GP, those should be taken as a upon r square, a upon r, ar and ar square. This I have given you. But what happens is, usually because you are doing MCQs, what happens is it's very easy that you take the options, substitute the options, and then you can find the answer. You don't have to go and do the quadratic and solve it and get the value of r. So that is not necessary. So even like somebody was talking about AP also, so same thing we are doing. We are not going into that. Why? Simply because you don't have so much time in the exam, because it's an MCQ. You simply just put in the options and try to find the answer. Okay. So that is the shortcut that I want to give to you, that you only find the value of A. That is very easy. So you do that. Once you get the value of A, so you have a reference point, and using that reference point, take all the three options and then try to substitute and find the sequence. Okay. So same thing applies for AP and same thing applies for GP. Just find A and then do it. So to find A, you will use this. Okay. A upon R, A and AR. If there are three numbers, and if there are five numbers, you will do this. Okay. So as we were talking about AP, similarly in the GP also you will have these type of sums. So that sequence is given to you already, and then you will be asked to find the nth term. Some terms, second times sums are that some terms are given, and then you are asked to find the GP. Okay, you are asked to find the progression. Third is you are asked to find the geometric mean, and fourth is you are asked to find the sum of the series. Do you remember those three formula you will be using? And other mixed sums. So in mixed sums, what happens? You will be given a series of numbers, and then rearranging those numbers, you will get maybe two GPs, or you may get one GP and one AP, and so you separate them, find the sum of those, and you will get the answer. Okay, so let us actually start doing some. So this is I think 6B series, exercise 6B, and we are doing the first 5 sums. Okay, clear up till now? Just put it in the. Kevin, which third point you want? Yes, Aditya, the same as the proportion formula. Okay. See, how do you know that two numbers are in GP, Lisa? Okay. You don't know. When do you say that it is a GP? Okay, when do you say it's a GP is when you have some other numbers also. Okay, so that time you say it's a GP. Yes, clear? Yes. In the previous slide, this third, okay, if series is infinite, okay, means what? Suppose I have this kind of series. 1, 2, 4, 8, 16. So what happens? What is the value of A? A is the first term, value is 1. What is the value of R? R is third term upon second term. So 1, 2, 3. Third term is 4. Upon second term is 2. What is the value of R? 2. Let us again see. R is equal to 2 upon 1. Second term upon first term. 2 upon 1, which is equal to 2. So common ratio is 2. Okay. So what happens is when I try to find this, when I try to find the sum of this, what happens is this goes on increasing. Okay. Can you see? The numbers are increasing. 1, 2, 4, 8, 16. So they are going on increasing. So to find the sum is not possible. But if I have 1 upon 2, 1, 1 upon 2, 1 upon 4, 1 upon 8. What is the ratio here? R is equal to third term upon second term. So 1 upon 4 into 2. So R is half. What about second term upon first term? This R is 1 half upon 1, which is equal to 1 half. So what is the value of R? R is equal to 1 half. So in this case, even when this series 1 upon 2, 1 upon 4, 1 upon 8, okay, this 1 comma. This goes to infinity, okay, because I don't know the infinite terms. So what happens is that here, as the denominator is increasing, what is the value? The value is becoming smaller and smaller. Okay, and so in that case, I can use this formula. Okay, S of infinity is A 1 minus R. So for this very example, I can find S of infinity. What is the value of A? A is 1 upon 1 minus half. Okay, R is half. So this is 1 upon 1 by 2, which is equal to 2. So sum of this series will be equal to 2. Okay, so that is what is meant by this. Okay, understood, Kevin? Yes, Shreyas. Shri, Miss Shri. Okay. Now the seventh term of the series 6, 12, 24 is. Now 6, 12, 24. Now to find the common ratio, R, you will write third term upon second term, and you will also, this should also be equal to second term upon first term. Okay, so let us see what is the third term. 24 upon 12. So R is 24 upon 12, value is 2. And let us see second term upon first term. So T2 upon T1. What is second term? 12. What is first term? 6. So what is this? This is also equal to 2. So given series is a GP with first term A is equal to 6 and common ratio R is equal to 2. Okay. Now what are they asking? So we are doing the first type of sums where the series is given or sequence is given and you have to find out the nth term. So I'm to find T7, T7. So what is the formula? Okay. What is the formula for the nth term? It is A R raised to n minus 1, right? For a GP, excuse me. A R raised to n minus 1. So this will be equal to A R raised to 6 because 7 minus 1 is 6. What is this? A is how much? 6. And R is 2. 2 raised to 6. Now this, for this only I have asked you to make this. Okay, here. I simply have to see 2 raised to 6. What is the value? 64. Okay. This is why this becomes easy. Or you can do it on the calculator also, 2 into 2 into 2. Just be careful that you are counting properly. Okay. So this is 64. So 6 into 64. How much is this? 64 into 6. It is 384. Yeah. So 384. Have you understood this first term? Yes. Quickly let me know. Clear? Yes, Tamanna. Very good. Meghna, Ritu. Okay. Sri Darshini. Okay. Yes. Very good, Ritu. Yes. Kevin, not 540. Okay. 384. It is R raised to 6. Okay. Yes, Rayesh Raj, Alpithangal, Nikita, Ruchika. Excellent. Okay. Now let us quickly go to the second one. T8 of the series. So you can now quickly do. Yes. See, when you're practicing, initially write down the formula as many times as you can so that by the time the exam comes, you have written it 100 times so that you will not forget it even though if you are not having done revision for a little time. So T8 is what? What is the first value? This is A. And what is R? Okay, R is equal to T3 upon T2, which is equal to 24 upon 12, which is equal to 2. And R is also equal to T2 upon T1. Make sure that you are doing it twice so that even if suppose you made a mistake here, you will quickly realize. Okay, so this is 2. A is 6. R, this is 6. R is 2 raised to 7. Okay. So 6 into 128 into 6, 768. So B is the correct answer. Okay, so again 2 raised to 7, you can quickly see the chart you have made and you can find the answer. Correct? Now let us see. Now here you may have ratios, as I told you, greater than 1 or less than 1. Okay. So let us see a negative ratio. So this is, I have to find A is how much? A is 128. Then I have to find R. R is T3 upon T2. So how much is T3 minus 32 upon 64, which is how much? 31 ones are, 32 ones are, 32 twos are, which is equal to minus half. And R is also equal to T2 upon T1, which is equal to 64 upon minus 128, which is equal to minus half. I have the value of A, I have the value of R. What am I going to do? I have been asked T12, so I am writing Tn is equal to A R raised to n minus 1 is the nth term of a GP. So I will write T12 is equal to A R raised to 11. A is how much? Minus 128. R raised to 11 is how much? Minus 1 half raised to 11. Okay. So this is minus, and minus raised to 11 will also be minus. So minus into minus will become plus. Why it has become plus? Because I have raised the minus sign in, up to an odd number. So you know that, isn't it? Minus into minus is equal to plus. But I have suppose minus into minus, it will become minus. Okay. So I have to use this rule. So minus into minus will become plus. So this is 128 upon 2 raised to 11. So I have to find 2 raised to 11. So I have already found out 2 raised to 9 here. 2 raised to 10. 2 raised to 10 is 1024. Okay. So this is 1024 into 2. Remember the chapter on indices? 2 raised to 11. Okay, 2 raised to 11 is nothing but 2 raised to 10 into 2. Okay, because this is 10 plus 1. A raised to m into a raised to n is equal to a raised to m plus n. Okay, so that is what I have used here. Now this is how much? 1024 divided by 128. So 128 ones are, 128 eights are. So this is 1 upon 8 into 2. So T12 is 1 upon 8 into 2 is equal to 1 upon 16. So C will be the correct answer. Okay. Now let us find the fourth term of the series. A is how much? 0.04. R is how much? T3 upon T2, which is equal to T3 upon T2, which is equal to 1 upon 0.2. Okay, which is equal to 5. 1 divided by 0.25. Now R is also equal to T2 upon T1, which is equal to 0.2 upon 0.04, which is equal to 0.2 divided by 0.04, which is equal to 5. Okay. So A is 0.04, R is 5. What is the formula for the nth term of a GP? It is given by A R raised to n minus 1. Okay. So I have T4 to be equal to A R cube. A is how much? 0.04. What is the value of R? 5 cube. Okay. So 5 cube is 5 into 5, 25. 25 into 5 is 125. So it is 0.04 into 125. So 125 into 0.04 is 5. So C will be the correct answer. Okay. Right. So these three sums. Oh wow, very good, very good. Aryan, which sum are you saying? No, Aryan, it will be minus into minus plus. Okay. So it will be plus 1 upon 16, not minus 1 upon 16. Ritu, which one you are saying B is the correct option? Okay. Yes, Kevin, very good, very good. Yes, Asif, good. Aisha, good. Kevin is also. Rabina, good. Yeah, very good. Okay, so let us quickly move to the next sums. The last term of the series up to 10 terms. So they want to see only the language has changed. Earlier they were saying find T9, find T7, T12. Now they are asking find the last term of the series. And they have written 10 terms, which means what? You are asked to find T10. Okay. So T10, they are asking you to find out. What is A? A is 1. Now what is R? T3 upon T2, which is equal to 4 upon 2. Answer is 2. Again, I cross check. T2 is T2 upon T1. That is equal to 2 upon 1, which is equal to 2. Okay. Formula. Nth term of a GP is given by A R raised to N minus 1. Once I've written that, I find T10. T10 is A is how much? 1. R is how much? 2. 2 raised to 9. Okay. Because it is 10 minus 1, so 9. What is 2 raised to 9? Okay. Quickly I see. It is 5 and 2. Yes. Fifth answer. Yes. 5 and 2. Okay. Because once you start writing it down, 2 square, 2 cube, 2 raised to 4, and then you see those numbers, so you quickly know this. Okay. So this is the answer. Now, the second type of sums we are going to do is some terms are given and you are asked to find the sequence. Okay. So let us do that. So this is example 2 on page 6.11. Find the GP where the fourth term is 8 and eighth term is 128 upon 625. This is a typical way. Okay. So just I'll write down. There is a typical way to solve it. Okay. Find ratio of given terms. Okay. Why we do that? So that we eliminate A. Then, like remember in AP when those two terms were given, what did we do? We subtracted. Two simultaneous equations were formed. We were able to subtract. Here in ratios, what is happening is that we have to find the ratio. Okay. We will not have simultaneous equation like that. What you will do, you will find the ratio between the given terms. That will eliminate A. And then you will be able to find out the value of R. Once you have found out the value of R, you will be able to find the value of A. Okay, so just remember this. You have to find ratio of given terms. If you follow this, you will not make a mistake. Now, what is given to us is T4 is given. How do I write T4? T4 is written as AR cube, 4 minus 1. This is given to me as 8. Then eighth term T8 is given as A R raised to 7 is given to me as 128 upon 625. Okay. Now this is first and this is second. Very important. Divide equation 2 by equation 1. Okay. This is what you must remember. So I have a r raised to 7 upon a r cube is equal to 128 upon 625 upon 8. Okay. Now, this a will get cancelled with this a. This is r raised to 7 upon r raised to 3. Remember, a raised to m upon a raised to n in the chapter of indices is equal to a raised to m minus 1. So how much will this be? R raised to 7 minus 3. So it will be r raised to 4. Okay. So I have r raised to 4 is equal to 128 upon 625 into 8. Now, this is 8 ones are 8 ones are and 6 are, right? 16 eights are 128. Okay, so this is equal to 16 upon 625. Now, r raised to 4 is written as, how can I write 16? 16 I can write it as 2 raised to 4. 2, 4, 8, 16. Okay. Anytime you can do that. 2, 4, 8, 16, 32. Okay. So 2 raised to 1 is 2. 2 raised to 2 is 4. 2 raised to 3 is 8. 2 raised to 4 is 16. 2 raised to 5 is 32. Okay. And 625 is written as 5 raised to 4. You will have to check, okay, because I already know it and I'm writing it because we have so many sums to cover. So 5, 25, 125 and then 625. Okay, so this is this. So r is equal to 2 upon 5. Okay. Taking the fourth root on all sides, you get r is equal to 2 raised to 2 upon 5. So I have the value of r. I can now easily find out the value of a. So I have I use the first equation, a r cube is equal to 8. So a I don't know, r is 2 raised to 3 upon 5 raised to 3 is equal to 8. Okay. So 2 cube and 8, they get cancelled out. So a will be equal to 5 cube. What is the value of 5 cube? It is 125. Okay. So what is the series? So first term is a. So what is how is the series given by? It is given by a, ar, ar cube square, ar cube and so on. Okay. So what is the value? A is 125. This missed out. Okay. So now what is A? A is 125. What is AR? It will be 125 into R. R is 2 by 5. What will be the third term? Third term will be, this is the second term, this is the first term. Third term will be equal to 125. R square is 4 upon 25. And so on. So this will be 125. If I solve this, 5 ones are, 5 25s are, so next number is 100. Third is 25 ones are, 25 fives are, so next number is 20 and so on. Okay. So no, this is AR, this is A cube, sorry. This is 125 into R square is 4 upon 25. So 25 ones are 25 fives are. So this is 20. Okay, right. This is 125. This 100 is not good. Yes. 25 into 2. 25 into 2 is 50. Okay. I was feeling that I'm not getting 2 by 5. See, just looking at the equation on the sequence, you can find out it's not in GP. So 50 upon 125 is 2 by 5. 20 upon 50 is 2 by 5. Okay. So this will be your correct answer. Darshani, fifth sum you want? Yeah, this is the fifth sum. Yes, Dimple, very good. Yes, Raj, Swati, Nikita, Kevin, Ritu. Yeah, very good. Yes, thank you, Kevin, Aditi, Ritu, for pointing it out. Yes, excellent. It's good to know that you are doing it with my speed, so that's very nice. Okay. Sri Darshani, I hope you are able to see that. Now, next sum we are doing is 125. Oh, this is the answer. Then we'll be doing the second term of a GP is 24 and the fifth term is 81. Find the series. Okay. Second term. Okay. T2 is what? AR. AR is equal to 24. And fifth term, T5, which is equal to AR raised to 4 is equal to 81. Okay. This is my first term. This is my first equation, second one. Dividing equation 2 by equation 1. Okay. How much do I get? That is AR raised to 4 upon AR, which is equal to 81 upon 24. Okay. This A gets cancelled. This R gets cancelled over here. You get 3. So you get R cube to be equal to 81 upon 24. So 3 8s are 3 2s are and 7s are. Okay. 27 3s are 81. So this is 27 upon 8. Okay. I can find the cube root. So R is equal to 3 into 3 into 3. 3 into 3, 9. 9 into 3 is 27. So this is 3. And 2 into 2, 4. 4 into 2, 8. So R is equal to 3 by 2. Okay. Substituting in equation 1, I get A into R is equal to 3 by 2 into A. Okay. Because this is the value of R. I don't know A, which is equal to 24. What will be the value of A? A will be 24 into 2 upon 36. 12 2s are 12 3s are. This is equal to no. 2 upon 3. So 2 upon 3. A is 2 upon 3. So 3 1s are and 3 8s are. So A is how much? 16. Okay. So just show it again. 3A upon 2 is equal to 24. Okay. 3A upon 2 is equal to 24 from this equation. So what will I have? A will be equal to 24 into 2 upon 3. So 3 1s are 3 8s are. 8 into 2 is 16. Now what is the series given by? How is the series given by? It is given by A, AR, AR square, AR cube, and so on. Okay. So I have, what is the value of A? A is 16. 16 into 3 by 2. 16 into 9 by 4. 16 into 27 upon 8, and so on. This is 16. This is 2 ones are 2 8s are. So this is 24. Then 4 ones are 4 4s are. This is 36, and so on. Oh, here also 8 ones are 8 twos are 2. This is 54. 16, 24, 36. So C will be the correct answer. Okay. So this is how you have to do it. Just write down whatever terms are given to you. Find the ratio. Find the value of R. Once you found the value of R, find the value of A. Then you can find the sequence. Yes, C is the correct option. Yes, Surya, Kevin, Aisha, Yashraj, yeah, Rabina. Yes, Dimple, correct. Aryan. Ritu, 3 by 2 was correct. Okay, let us go to the next sum, that is the 12th sum. Okay, now the sum of three numbers of a GP is 39 and the product is 729. Like remember yesterday in AP sum also we had this, that all the options were correct. There sum was the given number, that product was correct, but they were not in AP. So similarly here also, see, you are seeing 327, 9. The three numbers are remaining the same. So most probably all these three combinations are going to satisfy the equation. The two conditions, that is the sum should be 39 and the product should be 729. But we have to make sure that the option that we choose is those numbers who are in GP. Okay. Now let us see this. Option number, first let us check whether the condition is satisfied. So let us see what should be the sum of the three numbers should be 39. So we have 3 plus 27 plus 9. Okay, 39. And the product should be 729. So 3 into 27 into 9. 729. So all the three options are satisfying the condition. Now let us see the ratio. What will be the ratio here? 27 upon 3. 27 upon 3. What is the value? It is equal to 9. Let us see over here. 9 upon 27. Okay, third term upon second term. What is the value? This is 1 by 3. Are they same? Is it the common ratio? No. So this is not a correct option. Let us see over here. What is the ratio? Second upon third. Second upon first. So 3 upon 9, which is equal to 1 by 3. What is the option here? 27 upon 3. This is 9. So this is not the same. So this is also not the correct option. Now let us see over here. Second term upon the first term. 9 upon 3. Answer is 3. Now third term upon second term. This is 27 upon 9. What is this equal to? This is equal to 3. Okay. So C will be the correct option. Okay. So this is how you will be able to find out. So first check the conditions, that sum of the three numbers and the product of the three numbers first satisfy that the options which are satisfying those condition only you have to consider, and then you will have to see whether they are in GP or not. Clear? Now in a GP, the product of the first three terms is 27 upon 8. The middle term is. Okay. Now we are going to use the formula, not formula as such. It is just a way to simplify things. So three numbers are in GP. So what should I take? I should take A by R, A and AR. Okay. So what will happen is, so this will be my T1, this will be my T2, and this will be my T3. Okay. 3 numbers in GP. So what do I do over here? So they are talking about the product. So A upon R into A into AR. Okay. So this R will get cancelled. What will I be left with? This is equal to A cube. This is equal to how much? This is equal to 27 upon 8. Okay. They have given the product of the 3 terms is 27 upon 8. So what will be the value of A? A will be equal to cube root of 27 upon 8. What is the cube root of 27? 3. 3 into 3, 9. 9 into 3, 27. So this is 3. And upon 8, what is the cube root of 8? It is 2. Okay. So A is equal to 3 upon 2. And they are asking for the middle term. Middle term is this. So 3 upon 2. So 13. A will be the correct answer. Yes. Right? So simply by choosing that which will be the 3 numbers in AP, I'm just choosing A upon R, A and AR. I am able to do this. Okay. What if you are asked to find the geometric mean? Insert 3 geometric mean between 1 by 9 and 9. So what are my numbers? 1 by 9 and I have 9. Okay. So 3 numbers will be G1, G2 and G3. So 3 geometric means and 9. So what does it mean? This is my T1, this is my T2, this is my T3, this is my T4 and this is my T5. Okay. So what is this? This is nothing but A. Okay. What is my geometric series? Geometric series is given by A, AR, AR cube, right? So what is A? A is the first term. Okay. Now, so T5. What is T5? T5 will be equal to A R raised to 4. Where did I get that from? Because I know the formula Tn, the nth term of a geometric GP is A R raised to n minus 1. So T5 is A R raised to 4. So what is T5? 9. 9 is equal to, what is A? A is 1 by 9, R raised to 4. So R raised to 4 is equal to 81. So R is equal to 4th root of 81. How do I do this? I know 81 comes in the table of 3. It can't come in the table of 2. It can't come in the table of 4. So 3 is possible. So you have to keep trying that. If because this is an odd number. If it is not satisfied by 3, then you can try with 7. Okay. But here it is going to satisfy with 3. So R is equal to 3. Okay. So R is 3. A is 1 by 9. So what will be this? The first geometric mean, it will be equal to, this is A, this is AR, this is AR square, this is AR cube, and this is AR 4. This is 1 by 9 that I already know. Now let me find this. So which will be the geometric means here? This is equal to 1 by 9 into 3. This will be equal to 1 by 9 into 3 square. This will be equal to 1 by 9 into 3 cube. Okay. So these are the 3. So 3 by 9 is 1 by 3. This is equal to 1 and this will be equal to 27 upon 9. So answer is 3. So these are the 3 geometric means that you can insert in the given time. Yes, Anushka. Very good. Swati, what do you want again? Okay, just let me know. Okay, this sum. So I have to insert three geometric means. So I write down the two terms that are given to me, 1 by 9 and 9. I need three terms. So G1, G2, G3. Okay, three geometric means. But these all should again be in a GP. Okay, once I have inserted the geometric means, then original numbers and the geometric means, then they should again be in GP. So how do I ensure that? I ensure that by writing AR square, AR cube. So I must now find the new R, okay, new common ratio that is going to make this given this sequence into a GP. Okay, so I use this. So using the term, last term that is given, that is 9. So I find out that 9 is T5, which can be written as AR raised to 4. So using that, and I already have A. So I find out the value of R. Once I know the value of R, I can easily find the three geometric means. Okay. Now let us go to 6.12. Clear, Swati? Yes, Rabina, Dimple. 13th sum. Here, see, this is what I've been telling you, that there are certain typical ways to solve sums. So this is one of that typical way where you're choosing the numbers. You have to choose as A by R, A and AR. So the three numbers in GP should be chosen as A by R, A and AR. Okay, like in AP, we chose three numbers in AP should be A minus D, A and A plus D. Why do we do that? So that the D gets cancelled, we are left with A and it becomes easier to solve. I can't have one equation and two unknowns. Okay, so I have to eliminate one unknown so that I have only one equation and one unknown, and that I can solve, right? So that is why we are doing this. So I took the three numbers A by R, A and AR, and I solved it to find the value of A. And here they don't even want the series, they just want the middle number. So middle number is A, and A I found out, and that is the answer. So sometimes very simple things they have asked. But only thing is that you should know that what are the typical ways of doing it. So here the typical way is that choosing the GP as A by R, A and AR. Okay. Okay, Swati. So now let us go to 6.12, example number 1, where you have to find the sum. Now we are doing sum of the series. Yes, Tanmeet, clear? Very good. Anushka, clear? Yeah, very nice. Now the sum of the series. When I need to find the sum, first I have to find R. Because if R is greater than 1, I have a different formula. If R is less than 1, I have a different formula. So first sum to find sum of a series of an GP is this. Now R is equal to T3 upon T2, 4 upon 2, which is equal to 2, which is also equal to T2 upon T1, which is equal to 2 upon 1, which is equal to 2. Now since when R is greater than 1, S of n is given by A R raised to n minus 1 upon R minus 1. Okay, just write down the formula. Now, what is my value of A? A is 1. What is the value of R? R is 2. And what do I find? Up to 8 terms. So, what is my n? N is 8. Summation up to the 8 terms is given by 1. R is 2. 2 raised to 8 minus 1 upon 2 minus 1. R minus 1 is 2 minus 1. 2 raised to 8 minus 1. What is 2 raised to 8? Let us see. I can see from the chart also 2 into 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. So it is 256. So 256 minus 1, answer is 255. Okay. So this is my answer for the sum of the series. Yes. Now let us see the next one. So find the sum of n terms of this. Okay. Now, when I see this is a specially important sum. So 6 plus 27 plus 128 plus 629. Okay. So first check whether it is an AP. Okay. Anytime you are given a series, because we are taking a session on GP, you know all the sums are GP, right? When we took on AP, all the series were in AP. That does not happen when a sequence is given or when a series is given. What do you know? You don't know. You have to check whether it's an AP or a GP, right? So let us see whether this given is in AP. So if it is in AP, what will happen? Common difference T3 minus T2. 128 minus 27 is 101, and T2 minus T1 is equal to 27 minus 6. This is equal to 21. So, not an AP. Now, what happens? I have to check whether it's a GP. GP is 27 upon 6. The ratio R should be equal to 27 upon 6. So, this is 3 2s are 3 9s are 9 by 2. And then 128 upon 27. So, again, not a GP. Okay. Now, how do I find out? And it is asking me up to nth term. So, I don't know. How do I do this? Here, what happens is now I pay attention to the numbers. 6, 25, 128. So, here you can see 6 can be written as what? 6 can be written as 5 plus 1. 27 can be written as 25 plus 2. 128 can be written as 125 plus 3. And 629 can be written as 625 plus 4. Okay, so what I will write this series 6 plus 27 plus 128 plus 629 can be written as, this is written as 5 plus 1. Instead of 27, I am writing 25 plus 2. Instead of 128, I am writing 125 plus 3. Instead of 629, I am writing 625 plus 4. 625 plus 4 and so on. Now, I will rearrange. So, very important word is rearrange. So, I rearrange, okay. What do I do? I write down all the terms with 5 first. So, 5 plus 25 plus 125 plus 625 and so on. Plus, I will write the other terms 1 plus 2 plus 3 plus 4 and so on. Okay. Now what happens? This is a GP and this is an AP. Okay. This is a GP. How do I know that? 25 upon 5 is 5. 125 upon 25 is again 5. So there is a common ratio. How do I know this is an AP? This is simply 1 plus 2 plus 3, right? Remember the formula for sum of an AP of n natural numbers, n into n plus 1 upon 2. Okay. So here, what is this? Sum of a GP when r is greater than 1. Okay. Because this is 5, will be given as Sn is equal to a r raised to n minus 1 upon r minus 1. Okay. And what is this AP? AP, first n natural numbers is given by n into n plus 1 upon 2. Okay. So I have this to be equal to, what is the value of A? A is 5. So this sum of the series is given by 5 r raised to n. So that is 5 raised to n minus 1 upon 5 minus 1 is 4 plus, because this is also there, n into n plus 1 upon 2. Okay. So this will be the answer. So here you are able to just rearrange and get the answer. Okay. Yes. So let us take a small break, and when we come back, we will be doing further sums. Okay. Just go through this example that we have already solved, and you will be able to understand it well, so that whenever such a series is given, you will be able to do it. We know? Break le le? We know? Hello? Hello, welcome back everyone. Yeah, so let us go to the next sum. So now let us go to the next sum, which is this typical sum 3 plus 33 plus 333. Okay. Can you see this right now? Just put it in the chat box whether or not you can see the screen. Yes, Ritu, it is AP plus GP. Alpit Uncle, yes, RS5. Anushka, clear? Nabin, when did you have power as minus? Where have you seen this? Power of minus? Yes, visible? Yes, very good. Very good. Okay. Now, because I really want everybody to pay attention. So, whenever you see this kind of series, you start panicking. There is nothing to panic. You may get a series like this, or you may get series in decimals, or you may get it in fraction. Most of the structure of solving this is similar. Okay, so let us see this. Okay, now when you have such type of things, what you will do, first step is take out the common number. Now in this case, 3 plus 33 plus 333, you can see that the number 3 is common. So you take it outside and then put everything else inside the bracket. That is the first step. Then second step is divide by 9 and multiply by 9. Any number, if you multiply and divide by the same number, the number remains unchanged. So suppose I have this number 7. So if I multiply it by 9 and divide it by 9, what will happen? 9 gets cancelled. I will have the same number. But for rearrangement purposes, I am writing divide and multiply by 9. Okay. First step, take out the common number. Second step is multiply and divide by 9. Next is very important, write 9 as 10 minus 1. Easy. So let us try to solve this sum. Okay. So my series is given as 3 plus 33 plus 333 plus so on. Okay. I take out the number 3 common. What is left is 1 plus 11 plus 111 and so on. Okay. Now I will second step, divide and multiply by 9. So I will write 3 upon 9. So I divide by 9 and this 9 I multiply inside the bracket. In the numerator, I will multiply it inside the bracket. So this will be 9 plus 99 plus 999 and so on. Okay. Now this 9, I will write it as 10 minus 1. I will write 99 as 100 minus 1 and so on. Okay. So this is equal to 3 upon 9. What is this? 10 I will write as? The 9 I will write as 10 minus 1. 99 I will write it as 100 minus 1. Then 999 I will write it as 1000 minus 1. That is 10 raised to 3 minus 1 and so on. Okay. So this is equal to 3 by 9. Like we did in the last sum, I will write all the numbers of 10 in together and I will write all the other numbers together. So I will write this as 10 plus 10 square plus 10 cube. Now I will write minus 1, minus 1, this minus 1, this minus 1, this minus 1. Okay. I will just show you which minus 1. because this is 10 minus 1. This is also 100 minus 1. This is also this minus 1. Okay. So plus so on. Then I have minus 1, minus 1, minus 1. Okay, all these I am writing together. Now what I will do is, this is a GP. And this is simply an AP, or this is simply an addition. Okay, this is simply an addition. So what do I have is, this is equal to 3 by 9 and 10 plus 10 square plus 10 cube and minus. How many ones do I have? N ones I have, because I'm going up to where? Up to n terms. Okay, up to n terms. So this is minus n. Minus 1, minus 1, 1. So minus 1, minus 1, minus 2. Minus 2, minus 1. Again, minus 3. So this is also going to continue. This series is also going to continue. So this is minus n. Now this GP, what is the ratio? What is A for this GP? Just for this GP, A is 1, A is 10. And what is the value of R? 10 cube upon 10 square, which is equal to 10, which is also equal to 10 square upon 10, which is equal to 10. Now R is greater than 1. So what formula I will use? Sn. A R raised to n minus 1 upon R minus 1. So what is this? This is equal to 10. 10 raised to n minus 1 upon, this is 10 minus 1, which is equal to nothing but 10 upon 9, 10 raised to n minus 1. Okay. Now this can be written as, this 10 I take it inside the bracket. So what will I have? 10 into 10 raised to n minus 10 upon 9. Now 10 raised to n into 10 can be written as 10 raised to n plus 1. A raised to m into a raised to n is a raised to m plus 1. Indices minus 10 upon 9. Okay. So inside the bracket, the summation is this. So I have, this is equal to 3 by 9. Okay. This is what I'm considering. Okay. So 3 by 9, 10 plus 10 square plus 10 cube plus so on minus n. So for this, I'm writing this. This is equal to 3 by 9 upon 3 by 9, 10 raised to n plus 1 minus 10 upon 9. Okay. This addition is this. And I have this minus n. So minus n. Don't forget that. So now I have, this is equal to this 9. Here the LCM is 1. So 9 and 1, I take the LCM as 9. So 3 upon 9 into 9. This 9 also I take outside the bracket. What will I left with? 10 raised to n minus 1 plus 1. 10 raised to n plus 1 minus 10 minus 9n. Okay. So this is what I get. So this is equal to 3 upon 81, 10 raised to n plus 1 minus 10 minus 9n. So I can simplify this as 3 raised to 1, and this is 27 also. Okay. Yes. Where did it go? So answer is equal to, what is the sum? 1 upon 27, 10 raised to n plus 1 minus 10 minus 9. Okay, so this is how you have to solve this. Ashutosh, this is the way to solve it. So this is a typical solution, okay? There is no particular reason, only then this can be simplified into a smaller form, okay? Yes, Nabin, we are taking another example. So in that, everything will be able, you will be able to get it, okay? If your screen has stopped, Ankita, most probably it is your network connection problem, okay? I think the others are able to see it. Vinu? हाँ वो YouTube में दिख नहीं रहा है बोल रहे हैं वहां अभी तक ब्रेक का ही वो दिख रहा है हेलो हाँ वो YouTube आपके यहाँ चल रहा है अच्छा हाँ ठीक है क्योंकि किसी ने बोला है देखते हैं ओके सो जस्ट टेक योर नेटवर्क कनेक्शन देन please refresh your connection so that you will be able to see it properly okay yeah. Yes Dimple, thank you, you like my teaching, thank you Ritu. It's not difficult, you just have to remember 3 steps, okay? So take out common, multiply and divide by 9 and then rearrange it such that you will get a GP and an AP, okay? So let me take another example and you will be able to find out, okay? Now let us take it with the decimal. So that is my aim. जो डर बैठा है ना आपके मन में वो सब निकाल देना अपने को डरना नहीं है मैथ से you don't have to be afraid of maths and it is okay to make a mistake. See what happens when we make a mistake in the accounts, we don't get bothered, you know, we will do the next sum and we will not, but one math sum, if I make a mistake and I get it wrong, all my confidence goes away. Absolutely not, you know. We sometimes even think of only just make a bus, I just have to get my passing marks in maths. No, it is a very scoring subject, so you should try to get more, okay? Yes, and whenever you see on YouTube also, yes Nikita, yes Tanmit, good, it is visible on YouTube also, good, excellent. Okay, so now let us go to the next sum. So similarly what we have done, we are going to do here. But now the difference is, instead of 9 written as 10 minus 1, I'm going to write 0.9 as 1 minus 0.1. Okay. Instead of writing 9 as 10 minus 1, now I have the sum in decimals. So I'm going to write 0.9 as 1 minus 0.1. Is that clear? So let us do this. So my series is 0.7 plus 0.77 plus 0.777 and so on. Okay. So this is my series. So what is the first step? Take common out. So what number I'm going to take? 7. Okay. I won't take decimal out. I'm just taking the number out. So what am I left with? 0.1 plus 0.11 plus 0.111 and so on. Okay. Now, second step, multiply and divide by 9. So this is equal to 7 upon 9. What I do is I take the 9 inside the bracket in the numerator. Okay, so this is 0.9 plus 0.99 plus 0.999 and so on. Okay. Now, instead of 0.9, whatever written instead of 0.9, I'm going to write 1 minus 0.1. Okay, so here I'm going to write it as 7 upon 9. Instead of 0.9, I'm going to write 1 minus 0.1. Instead of 99.99, I'm going to write it as 1 minus 0.01. Then I'm going to write it as 1 minus 0.001 and so on. Okay. Now here what happens is this is equal to 7 upon 9. This is, I'm going to write all that 1, 1, 1. So this is 1 plus 1 plus 1. How many? N times. Okay. Because I'm finding the sum up to n. Then minus, I will put the minus sign and put it in bracket. Okay, this is an important step. So here it is minus and inside the bracket I have 0.1 plus 0.01 plus 0.001 and so on. Okay. Now R is what? Let me change the color only. What is R? R will be equal to T3 upon T2. So 0.01 upon 0.1, which is equal to how much? This is equal to 0.1, which is also equal to 0.001 upon 0.01. 0.001 divided by 0.1, which is 0.01 divided by 0.01, which is equal to 0.1. Okay. So I got the value of R. I have A. What is my A? A is equal to 0.1. So now this R, it is less than 1. So which is the formula I'm going to use? Sn will be equal to A 1 minus R raised to N upon 1 minus R, because R is less than 1. So I'm using this formula. So what is going to happen? What is the Sn equal to? Sn will be equal to A is 0.1 into 1 minus 0.1 raised to N upon 1 minus 0.1. Okay. So this is my value. So what am I going to write? And this is equal to how much? If I take this 0.1 inside the bracket, this is equal to 0.1 minus 0.1 raised to n plus 1 upon 1 minus 0.1 is 0.9. Okay. So now what happens is I can write it in point, or I can write it in terms of 9 by 10. Okay, so 0.9 I can write it as 0.9, or I can write it as 9 by 10. A I can write it as 0.1, or I can write it as 1 by 10. Okay, so choice is yours. It will again depend on what options you have. So this is equal to 7 upon 9. 1 plus 1 plus 1 n times is n. Minus, how much is this going to be? This is going to be minus 0.1 minus 0.1 raised to n plus 1 upon 0.9. Okay. So what do? I can, if I want, because in the book the answer is given in this form. So But I have taken decimals here. Why? Because it becomes easy to write. Otherwise, every time I'm writing 1 by 10, 1 by 10, so it becomes difficult. So whatever do, this numerator and denominator I multiply by 10. Okay. This numerator and denominator I multiply by 10, and then I get the answer. This is equal to 7 upon 9 into bracket n. 10 into 0.1, you will get minus 1 minus, this is equal to 0.1 raised to n upon, this is 9. Okay. So this 9, I take it outside. So this becomes 7 upon 9. This 9 into n will become 9n minus 1 minus 0.1 raised to n that is equal to 1 upon 10, right? So 0.1 raised to 10. Okay. So, oh, this 9 into 9. So what will I have? I've forgotten to multiply here. Okay. So here this will be equal to 7 upon 81, 9n minus 1. And what will this be? This will be equal to minus 10 raised to n minus 10. Okay. This will be minus 10. Okay. So this is how you have to solve it. Now the third type is this one. Okay, the third type is this one. This is, I've just taken it from the book. Whenever you have this type 0.75 with the 2 dots, any numbers which has these dots, it means that these numbers are repeating. So 0.2175, so 0.21 will remain like this. And wherever the dots are, so here it is 75, so 75, 75, this is going to be repeated how many times? Indefinitely. So that whenever you have this, so this can be written as 0.21 plus 0.0075 plus 0.00075, okay? Because this addition will give me this number, okay? And then you have 1 plus 1 by 10 raised to 2 plus 1 by 10 raised to 4 and so on up to 10 raised to 4. And then you will have to solve it. So this is a typical example where this is the way you are supposed to solve it. But I would ask you that you do other types of sums more, practice them more, because this is not a written exam. So in written exams, you have these types of sums, okay? These types of sums you are mostly getting when you have the, if you are doing CBSE mathematics or ICSE mathematics or state board mathematics exam, there you will have to solve this to like show the solution. But other than that, for MCQ, these are the preferred questions that you can see. Okay, so here what do I have is find the sum of the series up to 7 terms. Okay, so now first I have to check the value of R. R is T3 upon T2. What is the value of T3? Minus 18 upon 6, which is equal to minus 3. And R is T2 upon T1. which is equal to T2 is 6 upon minus 2, which is equal to minus 3, which is less than 1. So I will be using the formula S is equal to A 1 minus R raised to N upon 1 minus R. Okay. So what is the value? S will be equal to, what is the value of A? A is equal to minus 2. So minus 2, 1 minus R. R is how much? Minus 3 raised to N. N is how much? 7, because it is given to me as 7 terms, upon 1 minus minus 3. Okay. Now here, be careful, this is minus 3. So minus sign will come outside the bracket because this is minus raised to 7. So I have minus 2, 1 plus 3 raised to 7. Okay. 3, 1, 2, 3, 4, 5, 6, 7. So that is 2, 1, 8, 7 upon 1 minus of minus 3 is plus, so this becomes 4. Okay, so what do I have? This is equal to minus 2 into 2, 1, 8, 8 upon 4. So 4 1s are, 4 5s are, 4 4s are, and 7s are. So 547 into 2, which is equal to minus 1094. So A will be the correct answer. Okay, so A will be the correct answer. Clear? Now let us go to the sum of the series up to 8 terms. Right? Yes, very good. Swati, Ritu, Ayushi, Anushka, Dimple, Yash. That's what I'm saying, Yash. These are the type of sums you will get more. Okay. Now the sum of the series. As you can see, the number is decreasing. So value of R will be, is going to be less than 1. Okay. So R, which is equal to T3 upon T2, which is equal to 27. T3 is 27. Is 27 upon 81. So 9 3s are, 9 9s are, 3 1s are, 3 3s are, which is equal to 1 by 3. R, which is equal to T2 upon T1, is 81 upon 243. 9 9s are, 9 2s are, and 7s are. 9 1s are, 9 3s are. So this is also equal to 1 by 3. Okay. Now up to 8 terms. So I'm using which formula? S, which is equal to A 1 minus R raised to N upon 1 minus R. Okay. So here, what do I have? I have A. A is how much? 243. 1 minus 1 by 3 raised to N. N is how much? 8 upon 1 minus 1 by 3. Why I am considering the this thing fraction? Because here, can you see the answers are in fraction? So let me see. Okay. So how much is this? 243. And upon this is 1 minus 1 by 3, that is 2 by 3. So this is 2 into 3. I flip the fraction in the denominator. Whenever I have fraction in the denominator, it will flip. So 2 by 3 will become 3 by 2 into. Now what do I have here? I have 1 minus 1 upon 3 raised to 8 is how much? 3, 1, 2, 3, 4, 5, 6, 7, 8. 6, 5, 6, 1. Okay. How much is this? 243 into 3 is 729. 729 upon 2. and this is equal to 6561 minus 1. This is equal to 6560 upon 6561. Okay. So 2 ones are, let me show it in another color. So this is 2 ones are, and this will become how much? 3280. Okay. Now 729 and 6561. Let us see. 6561 divided by 729. How much is this? 9. This is 729 ones are, and this is 9s are. So I have 3280 upon 9. Let me see. How much is this? 3 3s are 27. 32 minus 27, 5. 58. 58 means 6. 36. 54. 40 means 364. 364 and in 4 by 9. Correct? 364 into 9 is 3276 plus 4, 3280. Okay. Do I have this in the option? This is 36, 36, 13 by 30, 36, 1 by 9. No, this is a big number. So none of these will be the correct answer. Let me just check. Do I have none of these? 9 sum. Yes, D, none of these. Okay. Yes, Dimple, D is the correct answer. Okay. So, understood? Please put it in the chat box whether or not you've understood. And if you're watching on YouTube, just put the like button so that we know. Yes, Aditya, we are taking the 10th one also. Okay. Don't worry. I know which sums you are afraid of. So I take all those sums. So don't worry. So here we are doing the 10th sum. Okay. Now, 1 by root 3 plus 1, 3 by root 3 up to 18 terms. Here, what I should do here is that I will write this 1 as root 3 upon root 3. Why do I do that? To have a common denominator. I repeat, instead of 1, I will write it as root 3 upon root 3. Instead of this 1, I'm going to write it as root 3 upon root 3. Why do I do that? That is so that I have a common denominator and I can take it outside the bracket. Okay, that is the only reason. And these are the smart things you will learn when you practice more. Okay, so this is written as 1 upon root 3 plus root 3 upon root 3 plus 3 upon root 3 plus so on. Okay. I can see root 3 is common in the denominator. I take it outside the bracket. So 1 upon root 3 I take outside the bracket. What am I left with? 1 plus root 3 plus 3 and so on. Okay. Now I must find R. R is T3 upon T1. T2, sorry. I don't have to bother about the 1 upon root 3. It's outside the bracket. It is already applicable. So I'm just going to concentrate on what is inside the bracket. So T3 upon T2. T3 is 3 upon T2 is root 3. Now remember in the chapter of indices, 3 can be written as root 3 whole square. Remember that? Upon root 3. Okay. So big hint, 3 is written as root 3 whole square. Okay, 3 is written as root 3 whole square. This is equal to root 3. Root 3 square upon root 3 is root 3. Now also let me check T2 upon T1. What is T2? Root 3. What is T1? 1, which is equal to root 3. So R is root 3. What is A? A is 1. Okay, A is 1. So root 3, is it greater than or less than 1? It is greater than 1. Okay, you have to put on your calculator 3 and then you just put the square root button. It is 1.73. Okay, so 1.73 is greater than 1. So I will use S is equal to how much? A R raised to N minus 1 upon R minus 1. Okay. So here This is equal to 1 upon root 3 into bracket. A is 1, R is root 3 raised to 18 because my n is 18 minus 1, okay, upon root 3 minus 1. Okay. Now, the most important part. I can simplify this and do this. Okay, I can find out root 3 raised to 18 and solve it, completed and this. But problem is that here things are given in this terms. 1 plus root 3 upon root 3. Second option is that you convert all this into a decimal value and you find out. Okay. So whatever decimal value you have over here, then you compare with the answer and you can get the answer. Okay. So here what, because the answer is in this fashion, you do this thing. If you remember in maths, simplify the denominator by multiplying and dividing by root 3 plus 1. Okay, because this is an irrational number, root 3 minus 1. So I have to use the conjugate. So root 3 minus 1, you will multiply by root 3 plus 1. Remember in the equations, chapter 1 equation, you must have already done this. So okay, so what am I going to do? I'm going to do this. So 1 upon root 3 into root 3 raised to 18 minus 1 into root 3 plus 1 upon root 3 minus 1 into root 3 plus 1. Okay. What else we are using? We are using a minus b into a plus b is equal to a square minus b square. So here this is a minus b into a plus b. Okay. So here this is equal to 1 upon root 3. Let us concentrate on the denominator. Just let me rub this off. I don't have space. Okay. So root 3 a square minus b square. Root 3 square will be 3. 3 minus 1 and 1 square will be 1. Root 3 square will be 3 and 1 square will be 1. So 3 minus 1. And what will happen over here? This is square root of 3 raised to 18 minus 1 into bracket root 3 plus 1. Okay. So now 3 minus 1 is what? 2. Okay. Now let me see what I can do with this. Now as you know, root 3 square is 3. Root 3 square is 3. So root 3 raised to 18. I'm just concentrating on this. Can be written as root 3 into 18 can be written as 9 into 2. 18 can be written as 9 into 2, which is can be written as root 3 raised to 2. Root 3 raised to 2 raised to 9. Okay. 9 into 2 can be written as 2 brackets root 3 raised to 2 raised to 9. Root 3 square is how much? Root 3 square is 3. So this is 3 raised to 9. Okay. So I know, I'm repeating, root 3 square is 3. Okay. Root 3 square is 3. I have here root 3 raised to 18. So this root 3 raised to 18, I'm writing as root 3 raised to 9 into 2. This 18, I'm writing as 9 into 2. I am writing this 9 into 2 as root 3 raised to 2 raised to 9. Okay, root 3 raised to 2 raised to 9. Remember this Everything is indices based. A raised to m raised to n is nothing but a raised to m into n. Just the opposite. So a raised to m into n can be written as a raised to m raised to n. That is what we are doing. So root 3 raised to 2 raised to 9 is 3 raised to 9. Now what is the value of 3 raised to 9? Let us see. 3 into 1, 2, 3, 4, 5, 6, 7, 8, 9. 19683. Okay. So 19683. So my equation, this equation that I have here, I will write down the equation. 1 upon root 3 and I had root 3 raised to 18 minus 1 into root 3 plus 1 upon 3 minus 1 is 2. This now can be written as, this can be simplified as this is equal to 1 upon root 3. Instead of root 3 raised to 18, that is 3 raised to 9. This is 19683 is equal to 19683 minus 1 root 3 plus 1 as it is I am writing upon 2. Now 19683 minus 1 is 19682. This is equal to 1 upon root 3 19682 upon 2 into root 3 plus 1. Okay. So this is equal to 2 ones are and this is equal to 9841. Okay. So the answer here is 9841 into root 3 plus 1 upon root 3. So A will be your correct answer. Okay. Understood? So A will be your correct answer. 9841 1 plus root 3 upon root 3. Okay. That is why we are most important step is this. Simplify the denominator by multiplying and dividing by root 3 plus 1. Remember in like whenever you have irrational numbers, you multiply it by its conjugate and you get the simplified work. Is that clear? Ardhendu, I will just look into this sum that you say. Ritu, thank you that you like my teaching. Thank you. Yes, Swati, you can get the screenshot. You can watch the video again on YouTube, and then you can find it. Yeah. Sum of x terms of 2 APs. Yes, I will be taking that sum. Okay, Ardhendu, I will take it. Maybe next time I will take it. Which term of the progression is this? Okay, now these are mixed types of sum where different types are given to you. Okay. So I think the most important one is this 14th and 17th. Let us do. Okay, this is easy, so you can do that. So let me take this because the time is also running out. If you save 1 paisa today, 2 paisa the next day, 4 paisa the succeeding day, and so on, your total saving in 2 weeks is. Okay. So I'm saving 1 paisa today, then 2 paisa the next day, 4 paisa the next day, and so on. And this is going to accumulate. So this is 1 plus 2 plus 4. How many days? 2 weeks. 2 weeks is 14 days, right? 2 weeks is up to 14 days. So my N is 14. My A is 1. Now my R, which is equal to T3 upon T2, which is equal to 4 upon 2, which is equal to 2, which is also equal to T2 upon T1. Just let us check. Is 2 upon 1, which is equal to 2. So my R is greater than 1. So what am I going to do? I'm going to just use S is equal to A R raised to N minus 1 upon R minus 1. Okay? Clear? So my amount saved, these are word problems. So actually it is the same thing like a numerical problem, but because words are given, so I have to just pay attention and take out information. Like 2 weeks is 14. So N is 14, those times. So amount saved in 2 weeks is equal to A is how much? 1. R is how much? 2. So 2 raised to 14 minus 1 upon R is 2. 2 minus 1 is 1. So 1 is there. So 2 raised to 14 minus 1 equal to. Now you have to just carefully on the calculator. 2 into equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is equal to 16384 minus 1, which is equal to 16383. But remember this amount because this is all in paise. Okay, this all 1 paisa, 2 paisa, and answer is in rupees. So this is paise, which is equal to how much rupees? 163.83. I divide by 100 is my saving. So 163.83. So C will be the correct answer. Okay. Now the next one is also very interesting. The sum of first 20 terms of a GP is 244 times the sum of its first 10 terms. The common ratio is, okay. Sum of the first 20 terms. Okay, so S20 is written as S20 is equal to A R raised to 20 minus 1 upon R minus 1, and S10 is equal to A R raised to 10 minus 1 upon R minus 1. What is the relation? S20 is equal to 244 into S10. You should be able to form this equation. This equation is the important thing. Once you know how to do that, there is nothing in the world that can stop you. Okay? Is 244 times this. So I just have to substitute. So what is this? A R raised to 20 minus 1 upon R minus 1 is equal to A R 244. Is equal to 244 into A R raised to 10 minus 1 upon R minus 1. Okay. This R minus 1 will get cancelled. This A will also get cancelled. What you are left with is R raised to 20 minus 1 is equal to 244 R raised to 10 minus 1. Okay. Is equal to this. So how much do I get? this I solve this bracket, open this bracket, r raised to 20 minus 1 is equal to 244 r raised to 10 minus 244. So I take this here, so I get what? This is r raised to 20 plus 243 is equal to r raised to 10. Okay, where has it happened? R raised to 10, 244. Okay, I don't need to open. Just let me, up till here it is okay. There is no need to open, otherwise you will, the calculation will become more tedious. You will get the answer there also, but here it will become easier. So what do I have here? Okay, now I will write r raised to 20 minus 1. This r raised to 10 minus 1, I will take it in the, this r raised to 10 minus 1 is equal to 244. Okay, now this I have, this I can write it as r raised to 20 is, can be written as r raised to 10 square. Okay, again, this is a plus b into a minus b is equal to a square minus b square. So r raised to 20 minus 1, I will write it as r raised to 10 square minus 1. Okay, like in the last time we have done, and upon r raised to 10 minus 1. So this can be r raised to 10 minus, this is a square minus b square format. This is 1, I can write it as 1 square. So this is r raised to 10 minus 1 into r raised to 10 plus 1 upon r raised to 10 minus 1. Okay, again, same thing, this cancels out. This is equal to 244. Okay, this is equal to 244. So now what do I have is, let me just take a black color so that you can see it. R raised to 10 plus 1 is equal to 244. R raised to 10 is equal to 243. 244, this 1 I take it to this side, it will become minus 243. Now which number, when I take it to the power of 10, I will get 243. Which number, when I take it to the power of 10, will give me 243. Since it's an odd number, I cannot have 2. It can't be 2. So let me try with 3. Okay. So 3 into 1, 2, 3, 4, 5, 6. No, but it is not coming. So in here I'm getting at 5 only, I'm getting 243. So that, okay, this is very interesting. So 3 raised to 5 is equal to 243. 3 raised to 5 is equal to 243. R raised to 10 is equal to 3 raised to 5. But you know, only when the powers are the same that I am able to equate the numbers. Only when the powers are the same can I equate the numbers. So instead of 3, what do I write? Instead of 3, I write it as root 3 square. Instead of 3, I will write it as root 3 square. Okay. So this is equal to root 3 square raised to 5. So this, instead of this 3, I am writing it as root 3 square raised to 5, which is equal to root 3 raised to 10. So r raised to 10 is equal to root 3 raised to 10. So what is the value of r? When the powers are same, I can equate the numbers. So r is equal to root 3. Now, another very important thing, because this is raised to 10. 10 is an even number. So you know that, suppose I have minus 4. Minus 4, if I square, what do I get? I get 16. If I square 4, then also I get 16. So when I see 16, I don't know whether it is a square of minus 4 or it is a square of plus 4. So here it is 10. I don't know whether it is root 3, plus root 3 or minus root 3. So value of r is plus or minus root 3. So this is very important that you remember that here, whenever I have even numbers, I don't know. So this plus or minus is very important. So that is why your option here, you have plus or minus root 3 and you even have root 3. But A will be the correct answer. Why? Because r raised to 10. So 10, I don't know whether it is the 10th power of an odd number, of a negative number or a positive number. So I have to choose this. Is that clear? This is a very interesting sum that I wanted to take with you. Okay. That there are lots of sums. Yes. Yes, Aishi, very good that you feel that explanation is very easy and you love my teaching. Thank you so much. Sindhu, please take on the website also, or if you want, I can upload this PDF of weightage of marks. Okay. Akshay Kumar, first you solve these sums and then you can go to AQB. Okay. Yes, yes, Nikita, it's a very interesting sum. Okay. Yes, thank you all for your patient hearing. I think we have done as many sums as possible, so you could do this. Okay, here also in the next sum, 3,000 per month, you have to just take the 3,000 and then find out the last salary that he can receive, and then you have to just find the summation. Okay. And in the next one, that is a person borrows 8,000 at 2.76 simple interest per annum. Here, first find out the simple interest, add it to the principal, and the total amount you have to get it in 10 installments. And so you will get that first installment is 8 rupees, and then you can find out the other installments. Okay. Okay. Yes. Yes, thank you so much for your patient hearing. Have a great day ahead. Okay. Yes. Thank you. Vinuji?